Hi all, myself Angel Sebastian, Assistant Professor in Department of Civil Engineering, Rajagiri School of Engineering and Technology. This session deals with highway intersections and its design. It is a topic in fourth module of the course Traffic Engineering and Management, which comes under APJ Abdul Kalam Technological University. These are the contents included in this presentation. Road junctions or intersections, its definition, need of intersection design, principles considered for design, then intersection types, grade separated intersections and at grade intersection. Then in at grade intersection we'll study simple intersections, its key elements and figure, then rotary intersection, key elements, figure, design considerations, and then a solved example for rotary intersection design. Junction in a road means area where two or more roads meet or cross each other. In other words, it is an area for vehicles to turn to different directions. These are hazardous locations in highway because vehicles moving in different directions want to occupy same space in same time. Here in this figure you can see it's marked as a collision point between A and B. This is a hazardous location. So, a designed intersection performs the function of minimization of the magnitude and characteristics of the conflicts, and also it helps the driver to select the proper route through which he need to move through the intersection. So these are the principles considered for design. First one, number of roads should be kept at minimum at the intersection. Means that some minor roads may be connected with each other to form a major road before joining them at the intersection. Next is geometric layout shall be suitable for safe movements. For that we can use channelizing, staggering, consideration of visibility triangle, radii of curves within permissible limits, etc. Another important thing is conflict points shall be minimized at the intersection. In some type of intersections, crossing conflicts are zero. These are some other considerations. Next is intersection types. Intersections are mainly divided into two: grade separated intersections or interchanges and at grade intersection. As its name indicates, grade separated intersection means roads are at different elevations and these roads are connected by ramps. Here you can see in this figure the elevated roads are constructed over pillars, and at grade intersection means roads at same elevation, and these are the three types of at grade intersection. So for grade separated intersection we have seen that the roads at different elevations are connected by connecting roads called ramps. These ramps are divided into three types: direct, semi-direct and indirect. So based on the type of ramp present in an interchange will be that type. For example, indirect, if direct ramps are present, then it will be a direct interchange. In direct interchange, you can see two conflict points in this slide. See this figure, black colored figure, can see if a vehicle coming from south direction want to go to east direction, you can see two conflict points at 1 and 2. Similarly, in semi-direct ramp, these vehicles coming from south direction will take a left turn and then it moves to the right going traffic. Then there will be only one conflict point. In the case of indirect ramp, you can see that this vehicle coming from south directions moves straight through that bridge and then takes a loop and then joins the right moving traffic. There you can see zero conflict point. These are the different types of grade separated intersections. Now we will see different grade separated intersections. First one is underpass. Can see a tunnel like structure in this figure. And then overpass. It is also known as flyover. Next type is trumpet interchange. In this figure you can see one highway is terminating over another highway. One straight highway you can see and one curved highway also you can see. This curved highway is terminating on the straight highway. This curved highway is not making any conflict points on this straight highway. The vehicle coming through that curved highway are moving along the bridge constructed over the straight highway, and then it takes turns to join the straight moving traffic. Another type is diamond interchange. Due to its shape, it got its name. It's a simple type of grade separated intersection. That is, when two highways meet each other, one highway will be constructed at a higher level so that vehicle moves through these bridges and there won't be any conflict points through the vehicles moving through other road. This type of interchange is known as full cloverleaf interchange. It got its name due to its shape's resemblance to a clover leaf. So, 4 loops are there for full cloverleaf interchange. These loops will be constructed at different levels. In this figure, you can see a full cloverleaf interchange in Chennai. Here, vehicles moving through elevated roads takes loops and changes directions. So, there won't be any crossing conflicts. This is another type of grade separated intersection. Its name is partial cloverleaf intersection, or in short par-clo. So here you cannot see 4 loops as in the case of full cloverleaf interchange. So if one or more loops of a cloverleaf is present, then it is known as partial cloverleaf interchange. The directions of movement of vehicles of full cloverleaf interchange as shown in the previous slide. This type of interchange is known as directional interchange. Here you can see direct ramps are present. We have seen in the previous slide that for direct ramps there will be 2 conflict points. But here, as this direct ramp is located at a higher elevation, vehicles can move smoothly without having conflict with the traffic in the lower roads. This is known as bridge rotary. This I can see a circular roads and roads at 3 levels. So bridged rotary is a 3-level stacked roundabout in which both roads or all the roads are grade separated so that conflict points can be avoided. So we have seen the different types of grade separated intersections. Next is at grade intersection types. Can see 3 types here. All paved or unchannelized intersection. In this type of intersection there will be no restriction to vehicles. So vehicles can use any part of the intersection area, and based on the type of intersection or based on the shape of the intersection they can be cross, T, Y, skew, multi-leg or flared, which you can see in the next slide. And another type is channelized intersection. In this figure you can see traffic islands are present. With the help of this traffic island, vehicles can follow a particular channelized path. So channels are spaces at a road junction over which vehicles cannot enter. Then comes roundabouts or rotaries. In this figure you can see circular region in the middle of the intersection. So these roundabouts or rotaries are specialized at grade intersection which introduces unidirectional circular movement of vehicles. Unidirectional. All the vehicles are moving here in clockwise direction. So the advantage of this roundabout is that no need of vehicles to stop at a point, and blocks also will be less. So here you can see T, Y and flared T type of intersection. So when one road comes and joins in another major road, it will be having the shape of a T, and you cannot see any channel in that, so it is known as unchannelized T. Similarly, another type of road is having the shape of Y, so it is known as unchannelized Y intersection. In flared T type of intersection, you can see that the road coming from the north direction is increasing its width too while it enters into the intersection. So, in an intersection, if the width of the road is increasing when it approaches the intersection, then that type of intersection is known as flared intersection. Here also you can see two unchannelized intersections which are having four legs, and all others are channelized intersection. You can see channels are given as triangles. So vehicles will move an ordered path in channelized intersection. And the last figure is a rotary intersection. In that also you can see vehicles are moving in an ordered path due to the presence of channelizing islands. Here also you can see different types of at-grade intersection. T intersection is meeting at right angle, and if the T is not meeting at right angle, then it is known as skewed T intersection, cross intersection, or when the angle of intersection is 90 degree, it is known as cross intersection, and if it is not 90 degree, then it is known as cross skewed intersection, a circular intersection. Then opposite four-leg intersections. If a road is not meeting, all the roads are not meeting together, one road is a distance apart, then it is known as opposite right intersection. If it is not meeting at 90 degree, then it is known as opposite skewed intersection. You can see 5-leg and 6-leg intersection also here. Key elements of at-grade simple intersection. Here you can see two highways intersecting at 90 degrees. So this intersection is having four legs. Different arrangements are made in this intersection for the safe movement of traffic and pedestrians. You can see pedestrian crossing, islands are present, roads are not intersecting with sharp edges, footpath can be seen. So the same intersection can be drawn by showing all the key elements like this. The angle of intersection is 90 degree. Then a major straight rod is shown horizontally and a minor street is shown vertically. Pavement markings. Pavement edge corner, it is not having a sharp edge. Then you can see channelizing islands, pedestrian ramp, sidewalks, crosswalk, etc. are present. This is also having 4 intersecting legs. Here also you can see two highways meeting at right angles to each other, and the difference from the previous figure is that here a central island is given. So this type of intersection is known as rotary intersection, and the key element of this rotary intersection are also shown here. You can see the central island in the middle. Then there are 4 legs of intersection. Each leg is divided into 2 parts with the help of splitter island. One part is for the entering vehicles and the other part is for the leaving vehicles. So there will be different radius provided for entering, approach and leaving lanes. 3 traffic operations in a rotary are diverging, merging and weaving. Diverging means vehicles moving in one direction is separated into different streams. So, the points in the intersection where diverging of vehicles occurs are known as diverging conflict points. And if vehicles coming from different streams merge together to flow through a single stream, then that point is known as merging conflict point. And weaving means combined movement of both merging and diverging. Here, in a two-way, two-lane intersection, you can see there are 16 conflict points. In the first figure, you can see the 16 conflict points are marked in blue color. In Indian condition, red color is given as diverging conflict points in this figure. When a vehicle comes from the south direction, it can take a left movement or a straight movement or a right turning movement. When the vehicle split to left turning traffic, there will be one diverging point, and when it split to right turning traffic, then there will be another diverging point. So 2 diverging points each in 4 approaching legs. So 8 diverging points will be there, and similarly 8 converging conflict points also will be there. So all these converging, diverging and crossing conflicts are shown here in blue, red and green colors in the first figure and second figure. So in a roundabout, you can see there is no crossing conflict point, only 4 diverging and merging conflict point. Now we can explain the advantages and disadvantages of rotary. We understood that traffic flow in only one direction only, thus eliminates all the severe conflict points. Severe conflict points means crossing conflict points. We have seen in the previous slide that all the crossing conflicts are getting eliminated when it comes in the case of a rotary intersection. Then second one is all the vehicles entering the rotary continue to move at a slower speed. So, and none of the vehicles need to be stopped, unlike in the case of a signalized intersection. Then lowered speed, it eliminates the severe conflicts and accidents. Another advantage is it is self-governing and it does not need any control by police or traffic signals. And another advantage is suitable for irregular geometry of also. Then limitation. All the vehicles are forced to slow down at this intersection. So cumulative delay compared to other type of intersection will be much higher. Even then, Even when there is no more or even then there is relatively low traffic, the vehicles are forced to reduce their speed. That is also a limitation. Another thing is it requires large area of relatively flat land. In urban areas, the area for land will be more. So cost of construction of rotary islands, rotary intersections in urban area will be more. One more thing we can tell as limitation is that this type of intersection is not suitable for pedestrian movement. The reason is that the vehicles do not usually stop at any point in a rotary intersection.